Alright, in this video we're going to go over some practice problems. They're going to have to do with retrieving something via HTTP protocol in Python using urllib.request module, and then also dealing with JSON data, and then dealing with the RE module, which stands for regular expressions. So we're just going to go through a few of these problems here and see what we can figure out. So here we have number one, create a module called rec.py with a function called getRig, in which you retrieve the string data from the text file hosted at the following URL. Okay, so if we click on this, this just takes us to a place where I'm hosting this file at cs.indstate.edu, and these are just a series of rig entries. The term rig stands for random identity generator. There's a Linux command, rig, and it just generates these random identities. It's useful for testing certain things. You can also say rig-c and give a count of how many of these things you want it to print out, and it prints a space between each one, right? So you can print out hundreds. So we're going to pair this with the idea of the grep command, right? So I can use the idea of the grep command. Grep basically takes standard input, so we're piping the standard output of this command into the grep command, and then we specify a pattern. And if our pattern matches one of the lines, grep will reprint that line. All the other lines will not be reprinted, right? So if I wanted to print any line that had BLVD, Boulevard, in it, we see there's one here up here at the top. I might have to run it a few times. So these are all different. They're random every single time, right? So I had to run that a few times, and then we finally got one with a boulevard. Or I could instead up the count. We'll up the count to 100, and we're pretty certain to get one then. Okay, so these lines, this is what grep does. It's a pattern matcher. It basically filters out lines that you aren't interested in and only shows you the lines that match the pattern you specify. Beyond this, grep has a way you can use regular expressions, which is very nice. We talked about this before. You can specify the -e option to grep, and then you can specify a regular expression, and you could do something like this. I want to find all of the lines. Let's say we wanted to find all of just the names, right? So these would be lines that start. So we use the caret that matches the start of a line, and we could say lines that start with a letter, right? And we would want to, let's ignore case, so we can just say it can start with a lowercase letter and it doesn't matter. So we want it to start with the letter, and then we want to say dot star. So the dot matches anything except a new line character. So star means we're going to match 0 or more times. So star is what's called a quantifier, right? So this is the thing we're matching, and this happens to be a set. That's any character except the new line character. This is also a set. We're specifying the alphabetical characters. So this is just going to match one character since there's no quantifier. Then we're going to match the set of any other characters 0 or more times, and then we're going to match another alphabetical character and then match the end of the line. Okay, so these are two special characters. This matches the beginning of the line, this matches the end of the line. All right, so this video is not about regular expressions. I'm just sort of giving you a quick summary here, so we're not going to go too much into that. If you want to know more about regular expressions, you can pull up the documentation for regular expressions in Python 3. Right, the RE module. Pretty much every programming language has some concept of regular expressions. It may be slightly different in each language, but it's fairly close, and it's very useful way to pattern match. You can look for certain patterns in strings. All right, so that's the idea. We're going to use this, and we're going to follow along with our practice problem set here. Okay, so back to our command line here, rig-c 100. So these are going to be all of the names. So notice how it's filtered out. All of a normal rig entry is 4 lines here, but we just wanted to see all of the names. So we used grep, and it only gave us the names because we specified this pattern where it starts with an alphabetical character, can have anything in between, and then ends in an alphabetical character. All right. So the whole idea of this practice programming set is to try to sort of mimic this concept. Now what we're going to do, instead of calling rig each time, because since that's random, we want to be able to reproduce our results. So that's why I've posted this file here, cs.indstate.edu/lma1/assets/rig.txt. This is just a text file hosted by the web server at indstate.edu, and it's just a bunch of rig entries. I have slightly modified a few of them to make sure we get some results. So some of the questions you might not, if you just did rig randomly, you might not get results. So I made sure that you'd get results on some of these things. Okay, so it's just slightly modified, and it's reproducible. So this gives us an opportunity to learn a few of the little modules that are convenient when you're writing Python programs. All right, so let's go back and see what we're supposed to do here. We want to create a module called rec.py, right? And it's going to use the urllib.request module, and we're going to grab this URL. We're going to grab the text from there and return it, right? So we want to make a function called getRig that uses this module, grabs the text here, and returns it. And then we're going to test the module by just running the function getRig and printing the text to the terminal. All right, so we'll get started here. We'll pull up, I'm working on my desktop here. This is the problems file that we're looking at. And then new file, this is a module, rec.py, and then I like to add the hashbang at the beginning, and I changed the mode. This is effectively chmod 755, but I can do it from my text editor. Okay, so what do we need to do for this? We need to import the module urllib.request. All right, and then we want to define a function getRig. And all this is going to do is basically call, access the URL, we'll get some data, and then we'll return that data, right? So to use urllib.request, you want to use the with command. And then we say .url open. Okay, then we just specify our URL, right? So we can just copy and paste this here. We know that works. And this is our request object. So we're going to say as request. Then to get some data, so this is going to be the text data, we're going to say request.read. And then we also want to decode that into, when you say just read, it gives you bytes. We want to decode that into UTF-8. So that's the standard string format we're used to. So that way this data is going to be string data. Okay, and what the with keyword does is basically this object here, there is some concept of something that needs to begin and end, and then a body of code. So here's the body of code. When you use the with keyword, it basically makes this this object is smart enough to know how to clean itself up. Okay, so that's basically that's loosely what the with keyword does. There's some startup stuff that has to be done, and it automatically knows what it needs to do to start it up and to finish it up, and then you just have to write the stuff in the middle. Okay, so this is common. You'll see this with writing files. You use the with keyword, so that way you don't have to open the file and then close it when you're finished. It just does it all at once. All right, so we have the data, and then very simply we just return that data. And that's really all there is to this. When you make a module, anything that's in the global scope here, the unindented scope, that is what is exported, right? So if I want to test this module, I don't want, anytime somebody imports this module, I don't want them to have to run the tests. So especially if I'm just doing a few tiny little tests, I'll do something like this. If name equals main, This is only true. This is a special Python variable that is only equal to main when the file that you ran from the command line is this file. Okay, so if I import this file, name will be the name of the module. But if I run this file directly, name will be main. Okay, so these tests will only run when I run this file directly, which is exactly what we want. All right, so to test this, I'm just going to say print and then get rig. All right, now we can run this with request, and it gives us these values. Every time I run it, I'm accessing the same values. I am making an HTTP request, so you do need to be connected to the internet, and it will access the same data each time. However, it is mostly data that was generated from the rig command. All right, so there, that satisfies problem 1. Oops, get that out of there. All right, now let's take a look at problem 2. Make a module called grep.py with a function to somewhat mimic the grep command line utility. You will need to use the built-in Python RE module, regular expressions. The function signature should look like this. Okay, so we've got a starting point here. That's good. So we'll copy that. Now we have the text that we're going to grep, the pattern that we want to match, and then before lines and after lines. So how does the before lines and after lines work? So let's say we wanted to we wanted to match all the names from a rig command, but then we also wanted to list out the addresses, right? So you can specify -a and how many lines after the match you want to print out. Okay, so this is just with the rig command. Now if I use -a, that prints out an additional line after, or I can use -b, capital B, and that'll print out a certain number of lines before the match. Notice the match is still here, colorized here. Now since there's multiple lines that are being printed out, grep automatically puts these 2 little hyphens in to separate the groupings. Okay, so we're going to need to do something similar to that. All right, now if there's no -a or -b, there is no little hyphen lines because it's only printing the lines that match. All right, so that's sort of the idea. And so this is our function signature, so let's start with that. New file, grep.py. I add the hash bang. Make it executable. I'll just paste this in. And we also are going to want to do the if name equals main trick again. And then we can run our tests in here. We'll make this a format string. And we'll use this other special variable in Python, and it'll be the name of the file that we're talking about here. So I can run grep here, and running tests for grep. Now notice these tests will only get run when I run this file directly. That's the whole point of this. We don't want the tests to run when I'm importing this module somewhere else, right? So I'll go ahead and add that to here as well. Running tests for this file. All right, so that's good. So now we need to work on grep. We need to basically mimic grep functionality. All right, so we get some text, and we want to have a regex. One of the things we can do is specify if this is a string, then we'll make a regex. We'll compile a regex, and if it's not, then we won't. So the main idea I'm going to go with, because it's sort of the first thing that comes to mind, is I'm going to take this text and split it up into lines, because that's what the grep command does. So I can use .split, and then I'll take that regex and I'll compile it and I'll match it on each line, and then go through if there is a match, I can match lines before or lines after, and then I'll have some output value that's going to be just a list of my results. Okay, so let's start by checking to see if this regex is a string or if it's actually a compiled regex. So I can say if type of regex is a string, then we're going to want to compile it. And so we need to import the RE module, and we'll say re.compile, and then we'll pass in that string. Okay, so this is just going to compile it for us. Now we don't have the option to add any special flags, and we'll talk about that here in a little bit. Like if we wanted to ignore case like we did in the grep command, there are special flags that you can add, and we'll talk about those later. Alright, so this is going to compile our regex if it's a string, and if it's not a string, we're going to assume it is a compiled regex. Or I guess we could say, if type regex is not re.pattern. So this is basically the class. This is the thing that gets created when you compile a regex. So if it's not one of these patterns, then we'll raise an exception. And we'll just say grep function must take a compiled regex or regex string as second argument. Alright, so that's good. We've protected against bad data there. We don't need to protect against everything. So we're going to have a results list here. And basically our results are just going to be the matched lines, right? And if there are before and after lines, we're gonna group those together with new lines. So a match is going to be a text blob, and it might have new line characters. It will only have new line characters if there are before and after lines as part of the match. Okay, otherwise it's just going to be a line of text. All right, so we start with our text, and we want to say, get a little space in here, make it look nice. We want to get the lines of the text, so we say lines is equal to text.split. We're going to split over the new line character. Okay, that should give us the lines. And what we're going to do is iterate through those lines. Now, we could, if we're just doing line matching and we're just printing out the item, we could just do a for loop, but we're without the index. But we're probably going to need the index because we want to reference lines before and lines after, right? So we'll say for I in range length lines. All right, and so we're iterating through here, and each of our individual lines, we need to check one of these individual lines. So we're going through each of the lines, and we're going to try to test our regular expression here. Now we've compiled it, so we know for sure we should have a regular expression pattern here. So what we can do is we can test for a match, and we can say our match is equal to regex.search. And what are we searching? We're searching this line of text. And then if we have a match, what do we want to do? Okay, so if we have a match, if it's simple, if there is no before or after lines, we basically want to have our results and say dot append the line, right? Because that line matches. That's simple, right? But that's not gonna be enough in the case of before lines and after lines. Okay, so what we want to do there is we want to think about this. So I could take a slice of lines, right? And it would include a starting point, which would be my match line minus the before lines. That would be my starting point. And then my ending point would be my match line plus 1 plus the after lines. Right? So we need a starting point that's going to be our index I minus the before lines. And then an ending point that is equal to I plus 1 plus the after lines. Underscore there, after lines. So why the I plus 1? Well, because when you take a slice of something, like if I want to define just the line I can do that. That's referenced by index, and it will just return that line. But if I'm taking a slice, I have to go from I to I plus 1 to get that same value back. Right? So this is just going to be the matched line. Right? But then I also want to start a little bit before that. Right? I want to start how many lines before? So I want to subtract the before lines here. So I would subtract the before lines here. And then over here I would add the after lines. Right? So that's all I'm doing with these two variables. So then this looks kind of messy, right? That's hard to read. So I just say start to end. I separated it out into two variables. So this is going to give us the match that we want to append, right? So this is what we want to append here. All right. So those are going to give us the lines. Now the problem with this though is this is going to give us a list. So we're going to append a list. That's not what we want. We want to append a string that has the new line characters. Each one of these items should be joined together with new line characters. So we can say new line dot join. Okay. So remember, these are individual lines, and we're taking a slice of a list of lines. So the list of lines, you take a slice of a list, it's always a list. So there's going to be like 3 lines in here, individual elements of a list, and we join those string values together with the new line character. So the result is just one string, and the new line character is basically in between each of the elements. So the strings are all concatenated together, and where they were delimited as separate elements, a new line character is placed there, right? Okay, so hopefully everybody's pretty familiar with the join function. All right, so that is going to give us a data blob of the matched line and any number of lines before and after the match. And that's going to be one element. It's going to be one string element that we're appending to our results. And then the end here is we'll just return results. All right, so let's test this. How can we test this? Let's try import rec, or rather from rec import get rig. We're gonna get rig data, and then we're gonna call grep. So that is our text, and then we'll have a regular expression. We'll get names again. We'll just copy the regular expression that we had from up here. Now when you're using regular expressions in Python, you want to use a raw string, because very often you're going to have to use backslashes, and if you use a raw string, the backslash won't escape like it normally does, and that's important, because otherwise you'll have to double escape all the backslashes you use, and it's kind of a pain. Alright, so we're going to specify this raw string. The start of the string, this matches the start of the string. This matches any alphabetical character. So this is a character set. It's going to match it one time, and there's no quantifier. Okay, so this is going to a character set. It's going to match any character, and the star is a quantifier. It means match 0 or more times. And regular expressions are greedy, so it's going to match as many as it can. And then we match one alphabetical character. and we match the end of the line. Okay, we have to make one alteration to this because we are not ignoring case, so we have to, the first one has to start with capital letters because these are the names. So that is our regular expression, and then we can ignore the before and after lines for now. So we'll get some result here. This should be a list of results. Let's print out the list. Let's see what we get here. Okay, so these it does look like it's the list of all the first names. That's good. So we could kind of print this out like the grep command would, and use join. So we're going to join with the new line character. Okay, so here is the list. It's just a list of strings, and what the new line character dot join does is in between each one of these elements, it's going to add a new line character. So we're concatenating all these together, we're joining them together, and between each one we're placing a new line character. Right? And so this is going to look more like the grep output that we're used to. And so that's effectively the same grep output as this, right? Except it's just not colorized. Let's see. We did get some different values there. Let's see. Why are our values different? Oh, it's because we're calling rig randomly here. Right, so this one changes every single time. Where ours, that's specifically why I'm using the data file that doesn't change, so we can make sure we get consistent results. All right, so that's good. So we have grep. That's a nice way to kind of do things. Let's play around with the before lines and after lines. All right, so let's try to get a value of, let's see, the rig command. If I want to match this line, one thing I can do is just check to see if it starts with a number, and then I can get the line before and the line after, 2 lines after, and that'll get the whole rig entry. So let's try that. We're going to try to match anything that starts with the address number 6, and that's only going to match the address line, because all the other lines, the name line starts with an alphabetical character, as does the city-state zip line, and the phone number line actually doesn't start with the number, it starts with the parentheses. So we'll say we want to find lines that start with 6, and we can print that out. So this should be all address lines. That's good. All the address lines that start with 6. And then we want to add the before lines. We want to say that's 1. So we want to get the name of the person as well. And we want to say after lines 2. So this will get the city, state, zip, and phone number lines. All right. So this is close. But what grep does is it joins these together using the double hyphen. So we got to add a little double hyphen in here. So this would be technically, so if before lines plus after lines is equal to, something more than 0, if it's greater than 0, we use this delimiter. Otherwise, we just use the new line delimiter. So we need to do something like that. All right, so now this is mimicking grep more accurately. So we'll say before lines, before, after lines is after, if before plus after is greater than 0, actually we'll just say join character. Okay, this is what's called a ternary expression. So this is the value that we're setting in this variable if this is true, right? Otherwise, or else, the value we want is the new line character. And then we can just say join character here. Alright, so this is just kind of a one-line way of, so I don't have to have a whole if statement here. Right? Join character, so the join character, or the join string rather, Alright, now depending on what you want, like this is mimicking grep exactly. I believe the problem says we should add spaces. So using the rig data, print only the city-state zip lines, then print out the number of matches. This one says with a blank line between each rig entry. Alright, so for these, we would not have the little hyphens. The little hyphens are more what we would do to more accurately mimic grep. Alright, so that's pretty good. We've tested that file, and now we can import this and use it elsewhere. So let's make a little function or another little module. We'll just call it helper.py. Call it, I don't know, lab. These are lab problems. Lab.py and same stuff. Make sure it says Python 3 there. Change the mode, 755. We're going to define a little function helper. We'll just call it lab. We want to import grep. Most of our lab problems that we're going to be doing, we can just specify, let's see, we want from grep, import grep, and from request, import get rig. Okay, and so for most of our lab problems, the data is going to come from get rig. So that's going to use the urllib.request, get that data, and then we're going to need some regular expression here. And then after lines, I think I have that switched. Before lines and then after lines. That would make more sense. Before lines, then after lines. So we get our data, and then we can call grep. So most of these problems here, the next problem here is we want to print out the you print out the matches and then print out the number of matches, right? So you always get a count at the end. So this is just a little helper function that's gonna help us get the count at the end. So we're going to say the results to grep are going to be data is the text, then we have the regex, and then after lines four lines. Alright, these are keyword arguments. So we get our results, and we can say, just like we did before, our join string is equal to, we want a blank line. So we're going to, normally we just join by the new line character, but if we want an extra blank line, we have to add an extra new line character. And we're going to say if after lines plus before lines is greater than 0, else just a new line character. and then we'll print join string dot join the results, and then we'll print the length of those results. All right, so we'll try a couple of these. If name is main, we want to, well, let's just do number 3 real quick. What, have we finished everything here? We've got the before lines specified how many lines before match. Just printed along with the matched line. Similar functionality for after lines. Function return should return each of the matches as a list, where each match includes the matched line and the before and after lines. Right? So each matched line is a string, right? And it includes the before and after lines. Yeah, so we got everything there. So here, number 3, using the rig data and these utilities, print only the city, state, zip line. So that's this line here. Then print out the number of matches. So we've made this little utility that's kind of nice. We can say our regex. Let's import re. So our regex is something that's going to match these. So it starts with a capital letter and ends in a number. That's kind of the quick, easy way. Or you could just say it ends in a number. That's less expensive, right? Because you'd have to match 2 things if you did it the other way. Either would work. When you're doing this stuff, you basically, it's important that you know your data, right? We know the rig command is always going to be matching this data format. In the real world, when you're talking about big data analysis, not everything is going to be formatted properly. So you probably want to use more exact regular expressions if you're trying to use them to match data sets to pull out different things, right? So we know that this is consistent. The rig command is consistent, so we can just check for the last item is, we could maybe do five digits to be safe, right? So let's do something like that. We'll say we don't match the beginning of the string, but we are going to match any numeric character. So this is the set of numeric characters. It's going to match it 1 time unless we specify a quantifier. We have a quantifier here of 5, so this is going to match 5 digits, and we want it to match at the right before the end of the string. Okay, so that's our regex, and what we want to do is call lab, and we want to match R, right? Okay, we just matched the regex, and these are optional. Okay, so let's see what we get there. Okay, so there are 676 total entries to this rig. So this should match every single rig entry, so there should be 676 entries. All right, what if I wanted to do before and after lines? Before lines, there should be 2, and after lines, there should be 1. Run it that way. So notice it's put a space between each one. All right, so that's pretty good. So that's working. So now let's just go ahead and answer problem 3. File executable. And now that we have all these helpers, it's pretty easy. We can just say from lab import lab, and basically everything we did in that lab test. And that's pretty much the solution. Oops. There we go. Need that in there. Not sure how that got in there. All right. Problem 3. So I like to import my built-in modules first, and then my modules that I've created in a second section below. And I have a couple spaces, and then I start my project. All right, so that's problem 3. Let's run it. And is that correct? Let's see. Only the city-state zip lines, then print out the number of matches. Okay, so we don't need the before and after. So we'll set those to 0. Okay, so notice the extra space, line of space, goes away when you're only matching one line. You don't use the before or after, so that's good. So that's good on that one. What's the next problem? Print the entire rig entry. So this is going to be all 4 lines with a blank line between each for all identities from either New York, California, or Indiana that are in cities that contain the characters NY, CA, or IN, regardless of the casing. Okay, so this is a little bit more tricky because you could have a city, Indianapolis, and there's a capital I, right? Or you could have a city, Albany, which has an NY at the end. So we're going to want to not use casing, right? So the way you do that in Python, if we take a look at the regular expression documentation, there's a flag re.I or re.ignoreCase. It's a shortcut. These two things are the same thing. And this is actually a digit. It's it's a power of 2. It's an integer, right? So if I run Python 3 and I import re.I, if I convert this to an integer, it's the number 2. There's also re.m, which stands for multi-line, and there's a lot of these different flags, and you'll notice that each one of them is a power of 2. Why is that? So the idea is if we have a number with a bunch of zeros and then a 1 and then a 0, this is a binary number, so this is the number 2, right, in binary. So there's only one 1 there, right? And this would be the number 2. I could also have a number like this, right? This is the number 8, right? So each one of these flags, if I join these together with bitwise operations, represents, I can use just one number, and I can specify basically multiple true or false flags, right? A 0 is false, and a 1 is true. So when I join these together, use bitwise operations. So bitwise operation, so re.I, bitwise operator to re.m, right? That should, if I convert that to an integer, that gives me the number 10. Now why is that? So that's an 8 plus a 2. So this is binary 10, right? And if I have this number and I want to see, so I just have the number 10 and I want to see if a particular flag is set, like I want to see, if for example re.I is set, then I can use the bitwise AND operator, right? I want to see if we have AND 00010. So this is the number 2. So if in this series of binary digits the 2 place value is a 1, then that gets ANDed with this 1, and the result is a 1, right? So as long as this is greater than 0, I know I have a match. all these other zeros are going to cancel out all the other flags. So it can't be a 1 based on that. All right, so, and, oh, let's see. So we specify a binary number in Python using 0b. And sure enough, the value is 2 because that's what we matched. We can do the same thing and check to see if the number 8 is in there. And it is. We can check to see if the number 4 is in there. And it's not. Okay, so that's how these flags work. You use bitwise operations, re.i. If you need to use more than one, you use the bitwise OR operator to join them together, and the result is just one number. So it's kind of a cool way to save space. You get a bunch of true or false values all as one number. All right, so what we want to do here, when I compile my regular expression, here's my regular expression, but there's some flags that I want to use, including ignore case. So I'm going to do the dash, comma, re.i. I don't need to join it with anything else, but so this is going to be the only flag that I have activated there. All right, so we're ignoring case. This is not the right file. We want to do this in the next problem. So let's duplicate this file. This is going to be problem 4. All right, and we want to find the city-state zip lines that have New York, California, and Indiana in them. Right? So we want New York or California or Indiana. Now this is not a bitwise operator. This is we're in regular expression land. This means different things. So this is going to match either the NY characters together, or it's going to match C and then A character, or it's going to match I and then N. And this grouping symbol means that it's only going to match one of those three things. Right? So it's either going to match NY, or it's going to match CA, or it's going to match IN. Okay, so that should catch the city. And then let's look how the rig entry is defined. So if there's an IN, a CA, or NY, CA, or an IN in the city, then we have a comma and then a space, and then we expect the state letters. So that means after this, we're going to have any number of alphabetical characters, A through Z, 0 or more, and we have a comma, space, and then we're also going to have New York, California, and Indiana again. Now I don't need to make these capital letters because we're ignoring the case. Right? So the comma and the space here is going to match on our rig entry. There's a comma and then a space here, and then we're going to match either these two letters, those two letters, or those two letters. Now I'm not matching the beginning of the string here. If I did, I would have to do something like A through Z again and match any number of characters at the beginning of the string. If I don't match the beginning of the string, then I don't need to do this extra part here. So it'll just match the first letters it finds, but it has to match all of this in order for it to be a match. And we don't want this to match the end of the string there because this part's not the end of the string. Is that right? So let's take a look. Yeah, our rig entry, we see, right, there's another actually 2 spaces here, and then our 5 digits for the zip code. Okay, so this should match. When we go to our problem, so we want all 4 rig lines. So the before lines are going to be 2, and the after lines are going to be 1. We can run this as problem 4. Did I not duplicate that file? Yeah, this is problem 4. Change mode. 755. There we go. It's executable now. Now I can run problem 4. So there should be 53 of these. Okay, so here let's check NY, and then here's the CA that's in the city name. There's NY, and then what do we have in here? IN is in there. Indianapolis, Indiana, that's going to work. California, you've got NY in the name. So these all appear to be working. You do want to go through and kind of double check for sanity just to make sure it's working. Binghamton, Albany, right? So that's good enough. So that's an example of solving that one. And then there's one more problem that's a little bit tricky. It requires us to give some information about ourselves. So this is my information. We're going to create, these two problems are kind of combined. So create a program called me.py, and we're going to use the JSON library, and it defines a dictionary, has some of our information. And then we're going to convert this dictionary into JSON, so a JSON text file. So JSON is a way of storing data, essentially, and it's cross-platform. It's used in many different languages. It's huge in the web, so it's very common to structure data with JSON. And it looks very much like a dictionary. The rules are slightly different, but it's very, very close. And so we have this dictionary, and we're going to convert that into a file called me.json. All right, so that's the first thing we're going to do. So we do that real quick. New file. We're going to say me.py is a program that's going to create the me.json file. So env3, change mode 755, and here we want to import the JSON, the built-in JSON module, and we have some dictionary me, and I'm just going to copy and paste this because just to save time. You guys can put in your information. What's up here? No. There's the problem. Copy that. Paste it in here. And what I want to do is I want to convert this to JSON. So I need to convert it to a string. The idea of JSON is it converts something to a string, and then that string can be stored in a file. Right? So we need some string data. So I'm going to end up with a JSON string, and I can use JSON dot dump string. Okay, so several of Python libraries use this sort of format. You dump the string, so dump means you're converting something to a string, and then the antithesis of this would be to load the string, so that would be load s. So you dump it to a string. What are we dumping to a string? Me, and then we want indentation equal to 4. And we can just print this out to start with, JSON string, and run the file. Okay, and you see that this is JSON. It looks very similar to just a Python dictionary, right? It is slightly different. There are rules, some sort of strange ones, like you can't have a comma at the end of the line. You can't have any comments in there, and all of your keys have to be quoted. That's the same for dictionaries in Python, right? So you use this in JavaScript. You use this in lots of different places. So it's a very common format to store data, and then you can load it back up in a dictionary or an object very easily in multiple languages. All right, so we have this. What we want to do with this now is create a file with this in there, right? So we're going to say, use that with keyword again. We're going to open a file. The name of the file should be me.json, and we want to open this file for writing, and we're going to call this file f, and then we're going to say f.write the JSON string. So there's that with keyword again. It just means that as soon as we get out of this code block, the with keyword is going to tell the file object that was created with open to go ahead and run its cleanup code as soon as we get out of the body here. So that's all the with statement does, and that saves us from having to do something like, file equals open, and then we'd say f.close. Right? That keeps us from having to do that. So you'll see this a lot of the time. All right, so when we run this, we should have a new file. And there's me.json, and sure enough, it's got our JSON data. I like my files to have a new line character at the end, so I'm going to modify mine a little bit to add a new line at the end. And that's just because, like, if I cat me.json now, but if I do it before it has the new line character, let's see, we'll run it again. There's no new line here, so my shell, I use Z shell, and it adds this %, and it's a little bit cluttered. So pretty much all my files I have end with a new line. Not important for the JSON spec, that's just a me thing. And so I'm going to add a new line character. And now when I cat, there's no %character because there's a new line. All right, so that's good. And then the last problem is going to use this JSON file. All right, so using the rig data, print only the name line and street address line. So that's 2 lines. The name line and street address line. So rig, so that's this line and that line. With a blank line between each set for all identities whose street address number is either the exact match of your birth month, birthday, or the last 2 digits of the account. Okay, so just for the record, all of this data is fake, right? This is not my birthday or anything, but I'm mimicking something here. So these would be the last 2 digits we're talking about. So in the account field, and then if you have a birth month or birthday, right? So since this is birth month of 3, we would just match that. Here, if we had something like 08, we would want to strip off that extra 0 and make it just 8. So I'll save mine as that for now. We'll go ahead and make it 08 because 00. There aren't going to be any addresses 00, I don't think. So we'll do 08. All right, so we want to find the name and then the address lines. And the address line should match exactly the 2 digits of your account, or 1 if it starts with a 0, or your birth month. So if it's 1 through 9, it's only going to be 1 digit. But if it's 10, 11, or 12, it could be 2 digits. And then the day. So the address must match one of those 3 things. So we're going to match on the address, and then we're also going to print out the name line as well. All right, so this is problem 6. Let's duplicate one of these. No, not trash. Duplicate. This will be problem 6. All right, so our regular expression is matching. We want to import, let's see, JSON. We want to get our me dictionary back, and so the opposite of JSON.dumps is JSON.loads. We're going to load the string. So we have to get the string first. Let's do with open. The name of our file is me.json, and we're going to open this for reading as f, and then we're going to say data equals f.read, and then we've got data, so that's our string data, and then we're going to convert that string data, that JSON string data, into the actual dictionary. So our dictionary is going to be back to being called me. So we've just undid everything we did in me.py. And we got the data from our file and turned it back into a dictionary. And so now what we want to do is we want to have a regular expression here. Let's call this R string, or just, I'll just call it R for now. We want a raw string here, but we also want a format string because we're going to be formatting some data from this. Right? So we want, you can have a raw string and a format string. So the values we want here, we want A is going to equal me account, me birth month, and me birth year. So this allows us to, this first one is going to be set to A, the second one is going to be set to B, and then the third one is going to be set to C. And these two are numbers. We want them to be strings. So we'll say, we'll convert them to strings. Yeah, actually we're gonna use the format string, so we shouldn't, yeah, that shouldn't be a problem. Now the account one we need to worry about because it could have a 0 in front. So we're gonna say A equals A if the first item does not equal 0. So if the first character in the 2-character string A does not equal 0, then the string we want to use is just that whole string. Otherwise, we just want to use the second character. So we're going to strip off that 0 character. Okay, so this again is one of those ternary expressions. All right, and we're basically making our regular expression here. So we're gonna place this in here when we're done. So what's our regular expression? So we want to match the start of the string, and we want to match one of several things. So we're going to use either the last 2 digits of our account, and we may strip off the 0, or we want to match our birth month, or we want to match our birthday, and then we have to add the space here. Otherwise, if I don't add that space, it could match, say we had 17 as our birthday, it would also match 174. So we have to include the space so it only matches that exact thing. Right, so it's going to match that. And that's the only way you can match that line. It's the only line that starts with numbers. So that's really all you have to have for the regular expression. And then the before line, we want to match just 1. This should be 0. And we'll see if this works. Problem 6. Birth year. Bad key. Oh, birthday. Yep. So problem 6 should be birthday here. Okay, save that. Right, so 3 March 21, 3, and then there were 3 total matches. So it looks like no matches for 8. We would probably want to double check that. It seems like there would probably be at least 1 match for 8. So what did we do wrong here? Let's print out A. Okay, so A is the entire item. Oh, I forgot to just take the last 2 values there. Alright, so there A is going to be the last 2 digits. So I'm going to take a slice and go from -2 to the end of the string. And now this should work. Yeah, there we got an 8 and an 8. Okay. So that's how you can use some regular expressions. We'll get rid of that last print statement, and these should all be good to go, and they should solve those problems. So hopefully you learned something just doing a few of these practice problems. It's kind of fun to go through and think of different ways to do them. Notice you didn't have to solve these this way. You know, we reuse this grep function a lot. It's just a starting point. We didn't have to necessarily do some of the things we did. If we were just trying to solve like problem 3, 4, and 6, we wouldn't need this lab function, we wouldn't need grep, but it gives us reusability and it gives us options, right? So that's something that you will probably want to think about when you're trying to solve a problem. You want to break it down into smaller reusable pieces as much as possible. Okay, so hopefully you enjoyed this, hopefully you learned something, and that's all I have for this one. So thanks for watching.